So a lot of what you've presented is essentially taking, complex systems, whether it's BIM, whether it's parametrics, whether it's, energy analytics and so on, taking field information, taking information from the desktop, the user, right? What's the hard part? What's, in terms of the scalability of it? Is it the collection of the data? Is it the processing of it? Or is it the output side, the end user? Like where's the hump in terms of effort?
I'll take a crack at it. For us, at least, the biggest side is collecting the data, being able to scale it where it's at a point that you don't need a specialized knowledge to do it. Anyone could do it. The general audience could do it. And it has to be maintained at good quality, because otherwise, bad data in, the results start to get dicey.
I would say for us, it's surfacing data in a way that users can consume it in an efficient way. Like that's probably our biggest challenge is, identifying methods of how we can actually surface the relevant data, right? Like, again, we have piles of it, but if they can't find it easily and quickly, then yeah, it becomes a problem.
I think for us, it's very much about sort of the expectations from our users. We're not necessarily dealing with data per se, but more sort of user experience. And that can obviously vary quite a lot depending on who you're talking to.
So for us, we really try to kind of develop a generalized way of consuming and feeding back the data for the users that could be useful in multiple applications.
Yeah, we've been using a lot of data that we have stored in our database, but of course it was not in a very structured form to begin with. So it was all unstructured data from various projects in different folders, and we had to pull it together and annotate them to train our models. So it was quite a bit of effort, but once we set a policy in place to keep an organized structure and have everything in a neat, organized manner, I think it made it much simpler.
Cool. So for years, we've realized that this kind of concept of data is important. I think back in like 2012 or so, our friends from CASE kind of had this logo, buildings equals data, right? So that kind of just spawned this kind of race to like aggregate data and collect data and just consume it because we may use it in the future, right? Maybe we can do this with it. Maybe we can do that with it, right? Based on kind of some of the efforts that you're all involved in, like how much of what we're collecting is actually useful? I didn't mean to stump them.
Oh, we're not sure who's going to tackle that.
I'm all the way on the right, so I go first.
So from my end, we're still very early in the game, and we've collected lots of data, and obviously we're going to come to a point where we have too much data that we can handle, but we're not there yet. And until that point, I think we're going to keep all of the data that we have available, and then once we have our models, of course, we also have trained hundreds of models, thousands of models, and we have many hundreds of checkpoints. If we want to maintain all of that, I think we're not at a stage yet where we'll discard data that we don't need, but I'm sure we'll get to that stage. I'm curious to hear how others are tackling that question.
I think on the Swarm side, we actually have a cop-out because we let our users decide what kind of data they want to pass through their models. And in a way, again, we're trying to really provide a platform that allows people to be flexible and kind of configure their workflow to suit their needs.
I think that was also a mistake we did with Asterisk. We basically started to sort of assume that every iteration of the building generation they made, we actually sort of saved a state of that. For the user to later sort of explore, which people didn't really like. So we didn't demo it here, but we've been working on something we call saved states, which allows you to basically run, a solution of your Grasshopper definition and sort of do like a little bit of a timestamp and, so be able to sort of revert there. So yeah, I guess the short answer is like we allow our users to basically pick and choose which data to see.
Yeah, in a similar fashion, we're probably the same way, where we're trying to provide tools for users to be able to aggregate and summarize their data efficiently, like where we have all of the information, but we're not necessarily showing all of it to the user at once. Like, it have to be strategic about the features that we're providing users to, be able to gang together filters and search queries and things like that to get the useful information that they need. But yeah.
Yeah, on the operation side for us, it's very similar. Like, we're collecting a bunch of data, but it's a culture change for these guys. So it's like the fact that they have temperature data, it's a great start, then runtime, then issues. So we collect the data, but we're selective in how we present it. Just as they learn, they continue to see the value of it. But deploying is a little different.
Yeah, I was really relating to the graveyard of dolls earlier in the TT core slide, because it's you often build these tools, processes, scripts, and then you press a button, you do the trick, and then the value is 0. We had that in process industry where we collect a lot of points, and the question is always like, why bother and keeping it? And especially time series data is kind of like getting big, and you don't pay attention, you don't post-process it. And I think on the flip side, what we've done with the branches is to be actually very critical on being as cheap as possible and only collect what we actually need, because we know that it's not liability, but all the extra stuff that you collect is baggage. You need to quality control it, you have outages, you need to get it back online, and then ultimately if nobody does stuff with it, then yeah, why bother, right? So the IoT is not, yeah, it's helping people now, I guess. It's mostly about like, well, why is it important to know what the thermostat was saying like 3 weeks ago, So it's, but the real-time processing, I guess, is the biggest challenge. And the other thing, I like what you were saying, the challenge is like we're very comfortable with writing script, automating, building processes ourselves, and users aren't. And the users, when they have a question, they want it now. They want it really quick. And then we need to, I don't know, teach the users to use different tools. I still think like automating Excel, silly stuff like that should be taught in college, and it's not, and that's what's wrong.
When it comes to the topic of scalability, right? So you mentioned this idea of, and a lot of us have done it, I'm guilty of it too, working on a project, you develop a script, it's awesome, but then the project meets its deadline, and now what, right? So now being able to take that and make that, tune it in a way that it's scalable for a firm, scalable for an industry. What are some of the kind of like lessons learned that, even though this script is, awesome in what it does, that beyond your desk, there's actually quite a bit more effort that needs to be done?
I would say for us, like identifying, we had kind of had this project-specific problem, and so abstracting that into a form that was more scalable than us actually manually creating, these forms and whatever else was important to us. But I think we're constantly fighting the line of, again, we focus on being a flexible tool that we kind of build these ground level features, but we also don't want to be too flexible and turn over the keys and say, hey, you can do anything with it, because then that might have wide applicability to everyone in the world, but no one's going to use it. So we're constantly battling that, balancing on that line of flexible but more specific. And a lot of that is just driven by like how we've determined the markets that we're approaching. So like, if we build tools for groups like this, that's great, but it's difficult to actually run a business, on the thousands of people versus hundreds of thousands of potential customers. But yeah, we're constantly trying to figure that out, where that balance is.
I think in our case, and I kind of brought this point up several times before the past few days, But there's a difference between kind of the end goal of building, say, a purpose-driven Grasshopper definition and actually turning it into a generalized app that is useful for many people. Because, in case of Grasshopper, it's kind of part of the workflow. Like you have a project, you have a particular set of conditions, and you can afford to be very specific to this one task, exactly because this tools later can be disposed. And, if you have to hard code some paths on your machine and it doesn't run on anybody else's computer, that's fine. So I think for us, when we actually propose using Grasshopper as sort of the backend for building applications for many people, for many users who will try to use it differently, it will require a certain cultural change of like, okay, now we're stepping into the domain of applications development and kind of trying to figure out how do I make a product that's usable by many other people.
Right, and many people, I guess, in this context can mean different things depending on the sort of application. So that's why we try to think of obviously different scenarios when it comes to, for instance, sharing apps and Swarm apps. It could be like, an author creates an app and shares it with a specific user and only one user. Another typical scenario is someone creates an app and wants to share it with their organization or company. And lastly, sort of the more kind of open one is a user or an author creates an app and shares it with everyone, sort of. So that's been a bit of a challenge to sort of make sure that we have, at least these three scenarios covered.
And in the context of T2D2, I mean, we've had several cases where we had to do several experiments. So we've trained our models on certain types of facades. Now we get a new type of facade. It won't work directly, so you'd have to probably do 10 different experiments on various types of pre-processing before you can say this is going to work. And what happens to those 10 different experiments? Do we just lose it? I think we decide if there's a particular process that has gone from experiment stage to the next stage, which is production stage, has reached a level of maturity, and we try to retain that information, but not necessarily retain all of the different experiments, but just down select, filter out the pertinent ones that have made the most impact, and then save it for next use. That's how.
It's an interesting journey going from like a POC, which is like a quick script, to a project, which maybe is for one customer, to product, which now you have to get into things like multi-tenancy and user settings. And for us, that was the journey in the branches. Getting to a product is tricky because you're bringing the information down to something that is specific to a user, yet the next month they can ask for something else. So how do you keep the product going? It's a bit more modular and more agile in terms of rolling it out. And then it gets a little more dicey. You're getting into things such as where do you host it? What if you have a user in like Vancouver, but you're in New York? Data quality, quality control is a big one. Planning ahead, and software can get expensive quickly. So it's a bit of orchestration, and agile has been something we've been using a lot to help us.
Yeah, I have two quick ones for that. One was the marketplace. I really like the marketplace, and I wonder if the marketplace ends up not being a marketplace for products, but more like GitHub, where people say software is like 90% is duct tape and copy paste, right? So maybe it's more going to be like the recipes have to be part of it, because people will want to study the recipe and copy paste from the recipe to learn and craft, but then the community that comes out of that is not the community that you're targeting right now. The other thing is with IoT, what we've observed, like the different, the PaaS guys, platform as a service, right? So Azure, AWS, the tool sets that are available to build IoT applications nowadays, it's not one. It's like you build an IoT application, you're looking at using like six to 10 different specific tool sets to orchestrate and route and collect and process data, right? And it's I don't want to say it's easy, because it's not. Ultimately, you obviously need to know what you're doing, but it's almost more efficient to set up from scratch for a project than to build this Uber design tool with too many bells and whistles that confuses just the wrong users. And it's like Rhino versus AutoCAD, you know? Like AutoCAD is a big dinosaur with way too many features, and Rhino just upended them with just being more flexible and nimble.
So we're going to open it up to the folks in the audience. I think there's a couple.
So I have a question more probably related to Charlie, a second question about how do we use the data, and this question will be more focused on the energy metric trends. So I guess because this all data we are collecting from the building is like it's operations data basically, but how do we get those data and the feedback to our like next generation design process, and then how, because as you said, all data we're receiving or we are monitoring all those data or whatever to optimize all the controls, it's saving the energy very minimum. But what's the reason why is that it's saving so minimal? And then you also pointed out one of the thermostat. It's just user is not using the building in a correct way, I would say. But I'm curious if any of your clients is getting your data and then to compare their previously like energy simulation data and then try to how to calibrate this kind of workflow and then make our next generation design process more efficient or might be more saving more energy, like while you're collecting those data.
I guess the cynical answer to that is we do believe in rebirths, and maybe in 3 or 4 more rebirths we'll have that. So we need to probably just wait a long time for that to happen. Because you're right, it's not happening. It was completely cynical, right? It's a joke. The other thing what you have is just the concept, and I think it fits with your question, is like what you want to do with a facility is you want to operate towards a simulated state. That's what you want to do. You want to have a facility and you want to say like, okay, with this weather, with this load, with this many people, you should be operating like this. And if you can compare that simulation with what you're measuring, then that's kind of like the holy grail. That's the promised land. And I think there's a very, very small number of projects where that's executed. We're not doing it. And yeah, keep looking. That's a good one to find.
Because I know because we have tried to work with several universities. They are also curious over the energy calibration and the real energy data, real data. So basically,
yeah, but this is almost like taking a submodel and a structural simulation and handing over not just the bridge, but also the model and the hooks to have the sensors validate with the model if the bridge keeps doing what it was meant to be doing, right? And there's also very, very few examples where that's being made, right? That's more the home turf of TT here, I guess.
I think we had an individual up there.
I have a technical practice question. When developing add-ins for Revit and Rhino, you're kind of stuck in a box with .NET and WPF. But when you move on to web apps, there are like 9 gazillion JavaScript libraries. How did you vet things like Angular and React and Vue.js? And did you leverage risk or try and decide what the risk was if one of these platforms you choose or libraries loses support, where you would be left?
Is that for me? So for us personally, when we were evaluating this moving forward, honestly, it was looking at first of all how we would be able to produce all of these different interfaces that we needed for tablet, desktop, and actually a Revit dashboard. How are we going to produce all of these different dashboards efficiently? Because during the prototyping phase, it was essentially just me building this in my firm. So like, in order to produce that, we needed to find a solution that we could build once and deploy everywhere. And so that we chose to stuck purely with web technologies, and we've kind of continued down that road wherever we can. Fortunately, we use Angular as a framework, but more and more every month, year that goes by, the portability from one framework to another is not easy, but we can, it becomes more accessible. So like with web components, if we needed to switch away from Angular, we could do that. It would be an undertaking, but we could definitely do it. You're right in that, and that's really what drove our primary, decisions as far as what we were working with is when you're working with web-based technologies, the world is wide open in what you can do, and so we focus on building from essentially one code base and being to deploy everywhere via web technologies instead of building specific implementations for different products. So,
Maybe we had one more up there.
So my question is for Sergey and Emil. I'm sure you are not surprised by that. On the topic of scalability, one of my favorite topics. Rhino, Grasshopper was not built for scalability. We all know that. But it has an incredibly robust and mature SDK and API, right? So Andrew Human accuses me of doing unholy things with Grasshopper, which is potentially true. But what that means is, document listening, onboarding flows, sophisticated UI, metadata embedded in Rhino files, custom schemas, cloud analytics. So, and actually, building a scalable app in Grasshopper is possible. It's not common, but it's possible. But when you look at the code base, about 80% of that is UI UX, right? Business logic accounts for 15 to 20% in my experience. And so the idea of being able to have a Grasshopper definition that computes in the cloud is fantastic. Like, kudos to your presentation and all the work you've done. It's amazing. But how do you account for the more sophisticated use cases, right, that allows an app to be truly scalable? Because just having a user account setting to share with everybody is not going to cut it, we all know, right? So do you have a plan, a philosophy for that?
So can you specify what you mean with scalability in this context?
Yeah, so scalability in the sense that I'm going to deploy it to, let's just take a use case, everybody in an organization for a particular design task. Scalability is that it can be deployed almost frictionless and utilized on n number of documents. And let's just take Rhino as the use case. That document is more than likely going to need to have app metadata contained within the document and have two-way binding between the business logic and the UI logic that's embedded in the Grasshopper document.
So I think that our attempt is not to solve computational design with Swarm. Our attempt is to cover the 90% where the workflow of the designer can be made much more efficient with a pretty simple Grasshopper script. Because you still see people spending hours in Excel copying the column trib areas and assigning them one by one. That's something that can be solved with a very simple app, and the ROI is insane, right? Yep. So yeah, we're not trying to shoot for 100%. We're not saying that everybody is going to use Swarm for everything, but you can use it for a lot of things.
Yep.
And I think the benefit here is that we figured out the back end and we figured out the front end kind of for you. So you don't have to exactly spend hours figuring out WPF bindings and you just upload your Grasshopper script. And what we're really asking people is to, just give us the business logic. Tell us what you want your app to do. We and Jeff Bezos will take care of the rest.
Yeah, I think that's fair. I am the edge case. You are right about that. But there is a continuum, right? Even relatively straightforward business logics require some amount of association of geometry, layer control. So there's probably some work to be done on that.
Let's talk.
Yeah.
Sounds good.
There is a hackathon this weekend, and they do have an API. Let's see if there's one more question in the audience. We got one down here.
Hi. So my question, I think, is more for you guys, but data is, I was listening to it's the new oil, right? It's worth money, especially personal data. You guys are collecting a lot of data. Do you look at how one building compares to another building, for example? Could you, or is it heresy to say if the temperature is low, could you start serving sweater ads on somebody's browser? You know what I'm saying? There's thought any other ways to monetize the data?
That's right.
And who owns the data?
That's a good question. So it's, at this point, it's, with the data and IoT, yeah, there's a lot of data law questions and privacy that are still being figured out. At this point, it's the customer that owns it. So we end up having to ask permission for things like today. But the big thing is it's portfolio management and an analysis and a ranking. Sure, you can compare building to building. Almost think of it like Uber drivers. They all have different stars. Well, facility managers have different stars, like how well are you operating your building? Because the most efficiently designed building doesn't necessitate the lowest energy consumption. It's how you use it. So it's more of a tool to provide information and dashboarding into these smaller assets that don't necessarily have it. So yeah, you can do ranking if you take it another step.
There was the leader laggard charts that he showed with the 4 quadrants and the green guys and the red guys. Like every dot is a building, and it's quantified, computed data that allows you to observe how your portfolio as a whole is improving or not.
Cool. Well, I want to give these guys a round of applause. Thank you, everybody.